Okay, so what the area I'm particularly interested in is in coupling. So that's the linking together of different models to solve a kind of a more complex scenario, and that's really the kind of the main thrust of the Hermitage project. So what I've been working on is the underlying technology which sort of supports all of the science that's going on. So the software I'm working on is called BFG, which stands for Bespoke Framework Generator. Actually, I'm a fan of Roald Dahl, so I called it BFG for other reasons first. The technology really, you take your individual models and you specify their inputs and outputs, the things they provide, the things they require, in metadata. So that's outside the model. You write it in a language called, well, it's in XML, something called XML. It's just a way of writing it in a file, really. And then you then specify how they're going to connect together, these models. So you have different inputs and different outputs, and you connect them up. And then you say separately how you want the thing to run. So whether you're going to run it on a single machine, whether you're going to run it in parallel, on a large machine, all those options you have. Then we have this magic button you press, and then that generates the code around the original codes, and you can then run them as kind of a larger problem. So that's fundamentally what our software does. Well, from our perspective, it's a generic technology, so you can input anything or output anything. For Hermitage itself, you can think of one of the outputs of a model might be CO2 emissions. So one of them might want to output CO2, another one might need it as input. So you just connect those things up. An interesting thing is I was talking earlier about this, and people think, if you say this model's connected to this model, it's very easy, you just connect it directly. But actually, it's much more complicated than that, because one model might output CO2. It may be distributed around the world. It may be points. It might have a certain resolution. It might go out at a certain rate. It might be in certain units. Another one might want something related to CO2, so you need to have to do transformations in between it. So when you link these models together, you end up with actually lots and lots of models in between, helping to make all the things talk to each other. It's like speaking different languages, I guess. You need an interpreter in between. So that makes it much more complicated. And of course, the other thing is that they're not just talking to each other once. These things tend to be models that are maybe iterating forwards in time, so you have time stepping, or they may need to actually converge to a solution. So you have to kind of iterate around in different ways as well. So you have to have that in as well. So it gets quite complicated. It is freely available. You can download it from our website. We've also, as part of this project, we've created a portal, BFG portal, which gives you free access to the software. You can run it online. You don't even need to download anything. You can just run it online, and it gives you results back. It also has some nice visualizations on it you can see. So one of the advantages of the tool, of having metadata and things, is you can translate that into other views. So we generate some of the graphs which show how the things connect together, which is quite useful for people to see, because people tend to write their own graphs. They don't actually necessarily know how the things are coupling. And one of the ideas behind Hermitage is to actually be able to record what people have done, so that people in the future can understand what's happened and can also build from that. So BFG helps in that. So that's a good question. I've been working on it for a very long time, actually, so probably about 15 years. It started off with requirements from the Met Office, actually. So it was for very much larger models, and it's found its way into climate change scenarios as well. I would like it to be used more. I think, in a way, when we first started, it was kind of too early for it to be used, because people are still just coupling one model to another model. And if you're just doing one thing to another thing, then you're probably best to do it just manually. But our system is very flexible. So if you're actually wanting to link this model in lots of different ways and couple it to other things, and you have this kind of more flexible coupling, linking together lots of different models, it comes into its own at that point. So I'm hoping that the community using it grows over time, and we can carry on getting research grants to carry on doing our research in it, and it takes off. Not directly, no. No, I mean we are kind of a support technology. So what will probably happen from those sort of things is people will run new scenarios, new simulations, and hopefully our software will help them do that. But in itself, it's not directly affected, no.